Welcome back to Knowledge Science Pulse, the podcast exploring the latest AI research. I'm your host Sigurd, joined as always by my co-host Carsten. Today, we'll dive into two fascinating papers, one on scaling and context learning with large language models, and another surveying the landscape of emerging AI agent architectures. Quite the dynamic duo. Carsten, can you give us an overview of the first paper?
Absolutely, Sigurd. The first paper investigates how increasing the number of examples or shots provided to a large language model during in-context learning affects its performance across various tasks. The key finding is that transitioning from few-shot to many-shot learning, using hundreds or even thousands of examples, leads to significant performance gains.
That's really intriguing. Can you give us some specific examples of the tasks and performance improvements they observed?
Sure. They evaluated on tasks like machine translation, summarization, planning, and code verification. For instance, on English to Kurdish translation, using 997 examples, boosted performance by 4.5% over the one-shot baseline, even outperforming Google Translate. Similarly, for text summarization, 500 examples matched the performance of specialized fine-tuned models.
Incredible. And what about more complex reasoning tasks? I'm particularly interested in their findings on problem solving and question answering.
For math problem solving, reinforced in context learning, where they used model-generated solutions instead of human-written ones, outperformed using ground truth solutions, even on out-of-distribution problems. On the challenging Google-proof QA benchmark, reinforced in context, learning with 125 examples surpassed the state-of-the-art.
That's really promising for reducing our reliance on human annotated data. This holy chower. Now, let's move on to the second paper on AI agent architectures. What were the key themes and considerations discussed?
The survey covered both single-agent and multi-agent architectures, highlighting their respective strengths. Single agents excel when problems are well-defined and don't require external feedback. In contrast, multi-agent systems thrive when collaboration and parallel execution are needed, though they're more complex to implement.
I can see the value in both approaches depending on the use case. What about some specific examples of agent architectures and their capabilities?
One notable single-agent method is React, which interleads reasoning, action, and observation steps, improving trustworthiness. For multi-agent systems, architectures like embodied LM agents showed the impact of leadership and dynamic team structures on task performance. The survey also discussed challenges like benchmark limitations and mitigating harmful biases.
Fascinating insights into this rapidly evolving field. Thank you, Carsten, for that stellar overview. Listeners, stay tuned for more cutting-edge AI research on our next episode of Knowledge Science Pulse.